Hi. What we're going to do is we're going to look at section 8.2, which deals with absolute values. And they're pretty much each time you approach one, I'm going to give you a list of questions that you can ask and do in order to solve these. So here we've got in this extension, we'll extend what we did in section 8.1 to include equations that have absolute values. All right, now that this is a formal definition of an absolute value. And most of you realize that when you have an absolute value, the symbol we use are these lines here, and whatever comes out is always positive. So this means in math that if x is negative, you would use this part. It's one of those piecewise equations. So if x is negative, this means you take the opposite of it because it will become positive. If x is already positive, you leave it. So this is the formal definition, and this is actually what we're going to use in order to solve some of these equations, and it won't be too difficult. All right, just remember that they always need to be positive. So let's look at a few examples here. Find the solution set. Well, we know that you're looking at the, let me move this up. We know that we can have the opposite inside, and we can also have just x. We're going to use that definition in order to define these. And most of you are thinking, well, if you put in 4, the absolute value is 4. If you put in a negative 4, the absolute value is 4. So you can pretty much do these in your head. You don't really need to write out the equations formally, but this is what you will need to do when they get more complicated. But you could look at this and say, okay, x can be 4. The absolute value of 4 is 4. Or x could be a negative 4. So in this case, we have two solutions for our x, 4 and a negative 4. Now, what if you wanted to, well, here, let's go ahead, setting it up where you have the opposite equaling the 4 and the x equaling the 4 and solving these. This one's already solved. You divide by a negative 1. So we'll be using this method here quickly. But here you could just look at it and say, okay, we've got to have positive. So it could be a 4, absolute value of 4 is 4, and the absolute value of a negative 4 is also 4. So you could put either one of these in, either one of those in for x, and it will work. If you were to graph this, and here, because we were graphing a lot in the last section, it's not arrows, it's just dots. We have arrows when we have our inequalities. So if they do ask you to graph the solution, you would just put dots above those two. You don't have the arrows because it's not an inequality. It's just a specific number. It's not an interval of numbers between two. Now let's look at this one. What numbers could I put in and have the left equal the right? Well, obviously the only number I could put in would be 0. That's the only solution. What about this one? This one's kind of a tricky one. What number could I put in, take the absolute value, and have it be a negative number? Well, you cannot do that. So when you have an absolute value equaling a negative, all you have to write is no solution. And you're done. There is no solution. Absolute values always equal a positive number, never a negative number. Okay, what we're going to do is we're going to go through some steps that you can take in this next box to solve these. If you cannot do them in your head, we're going to use this process here, but we're also going to make sure that it's not this before we go through all of this to solve it. So again, just looking at it, you can solve these, but we can't do that in all of them, especially this next one. Well, some of you may be able to. All right, so our first step in solving these equations with an equal sign. We'll also use these pretty much these steps with an inequality. They just have a little extra idea. First, isolate the absolute value. So if you have anything over here outside of the absolute value, you need to move it over to the other side. And in this case, we don't. So we do not have step one, but we'll do some examples where we do. Now, number two, if C is less than 0, so that if this number here, this is what this number 2 means. If this number is a negative, then it's no solution. So again, if it equals a negative, once this is by itself, if this is a negative, it's no solution. That's number 2. Save you a lot of time if you could recognize that. Number 3, if C is greater than 0, you make 2 equations. Now, I'm going to do things a little bit different. I'm going to move the negative over here. So we're going to have what's inside can be positive and what's inside can be negative, because that's the exact same process we're going to use for inequality. So it makes it so it's all one process. Solve each equation. And 5, the solution is a combination of all solutions to the separate equations. All right, let's go ahead and look at this idea. First off, the number 1 is met. Okay, we have the, I'm going to move it up a little bit. The absolute value is by itself. Also, number 2 is met. It doesn't equal a negative, it's a positive. So we're going to split it into 2 equations, and this is where people stop. What they do is they just take this one and solve it, and they're done. But what's inside, you're missing a solution if you do that. You'll be missing, because look at this other one up here. We had 4 and a negative 4. You'll be missing this solution over here. Well, here we have what's inside can be positive. Also, what's inside can be a negative. Let's go back to this and explain that again. And you'll do this with all of them, even the inequalities. I will show you a shortcut on one inequality. So what's inside can be positive, and what's inside can be negative. So you have to have both of those solutions when you have an absolute value. All right. So we solve them, and then we're done. So we add 3. X equals 8. All right. This next one, you could divide by a -1 both sides, and you have a -5 over here. I found that most people, when they're solving this, they like to use the distributive property, multiply a -1 through, which gives us a -x plus 3. So I use the distributive property. And now you solve them. -3, -3. Then you divide by a -1. You get a -2. So those are your 2 solutions. I would check it. If you were to put 8 in for X, 8 minus 3 is a +5. The absolute value of a +5 is 5. Put in a -2. A -2 minus 3 is a -5. The absolute value is a +5. All righty. So again, I need you to remember that when you've got the absolute values, you have 2 separate equations. What's inside can be positive, you just write it like it is, or what's inside can be negative. And the reason I'm using this process, and you don't have to, but this process carries over to inequalities very easily. And the next way, you only have to know one way of doing all of these, whether it's an equal or an inequality. All righty. Let's go on. Let's practice these ideas here. Again, our first step is to get the the absolute value by itself. It is. So we don't have to move anything. It's all by itself on the left-hand side. So now also check, does it equal a negative? No, it doesn't. So we can go ahead and set this up. So we've got 1 and 2 done. And now we're going to go ahead and set this up with our 2 equations. Okay, sorry, I had to pause it for a second. So let me back up. So the absolute value is by itself. It doesn't equal a negative. So we're going to split it into 2 separate equations. So here we'll have 2x plus 5 equals 13, or the opposite of that number inside can equal 13. And you solve both of those, check it, make sure they both work, make sure you've done it correctly, and you're done. So again, 2 steps here, subtract 5. 2x equals 8. Divide by 2. X equals 4. All right, so our x is equal to 4. That's kind of a funky 8 there. There we go. All right, so we have x equals 4 as a solution. Let's go to this one. We're going to use the distributive property. Multiplying by a -1, both of those. So now we solve it. Equals 18. Divide by a -2. X equals a -9. Let's put those in and see. You put in 4. 2 times 4 is 8, plus 5 is 13. The absolute value of 13 is 13. Put in a -9. 2 times a -9 is a -18, plus 5 is a -13. The absolute value is 13. So both of those solutions work. -9 and 4. Perfect. All right, let's go through B. Again, step number 1, the absolute value is by itself. Step number 2, the absolute value can only equal a positive number. This is a negative number, so there's no solution. If you were to accidentally go ahead and solve that, when you put the numbers back in like we did, they won't work. So, all right, it just saves you some time recognizing that step number 2. Okie dokie. Let's go ahead and go through this one right here. Now it's got a different format. It looks a little bit different. It looks more complicated, but it's not too bad. Given that f of x is equal to 2 times the absolute value of x plus 3 plus 1. Find all x's. So we want to find our x's when the function is equal to 15. This is the function. Okay, the function is equal to this. So when does this equal 15? So they're asking, using a lot of math symbols here, they're asking you to solve that. When does the function, this is the function, it tells us the function is equal to this. When does the function equal 15? So let's go through this process. We're going to do step 1. We have to have the absolute value by itself. So we're going to do that. Get rid of what's being added or subtracted first. Divide by 2. All right. Oh, sorry. I did that on the last one too. I think it was the same number. It's weird. 7. So there's our step 1 in solving this equation. We got the absolute value by itself. Step 2, Once you've done that, you do step 2. Don't do step 2 until you've done and completed step 1. So, all right, because if that would have been a negative number, it may have still worked by the time you got the absolute value by itself. So kind of keep that in mind. Step 2, we have to make sure it equals a positive, which it does. Great. Now step 3, we're going to make 2 equations and solve both of those. What's inside can be positive. What's inside can be negative. And you solve both of those. Am I going to have enough room? Yeah, I think so. Subtract 3. X equals, 4. Okay, I crossed that off a little bit too soon. 7 and a negative 3 is 4. One solution. This one will use the distributive property. Add 3. So then we have a negative x. I'm going to take it over here. A negative x over here on the left equals 10. Divide by a negative 1. X equals a negative 10. Okay. And then you would put each of those back in. 4 plus 3 is 7. The absolute value is 7 times 2. Then you get 14 plus 1 is 15. And then you can put in a negative 10. A negative 10 plus 3 gives you a negative 7, but you take the absolute value. Once you've done what's inside, you'll take the absolute value. So a negative 7 gives us a positive 7 times 2 is 14 plus 1 is 15. So they both work. Perfect. All right. So again, I think this is something that I figured you might have known already, is that when you substitute these in, you take the absolute value after you've done what's inside. Then you take the absolute value and then multiply and add. All right, this next one, I guess they're not numbered, so. All right, this one isn't as bad as it might look at first. We just have to do 2 sets here. Again, the absolute values are pretty much by themselves on both sides. You know, they're not going to have you do step 1 with this. Step 2, you know, a positive and a positive. Both sides are positive. You don't have a negative. So now what we're going to do is both of these could actually be positive. They could be the same. So we'll write 2x minus 3. We have to have 2 equations. We've always had 2 equations. Here we had this one right here. They're both positive. And then this one right here, one of them is opposite. So we've created this one where we just wrote both of them. Now we're going to create this one where one of them is opposite. And you can pick which one you want to be opposite than the other. And let's just do this first one. May have been easier to do the other one, but that's okay. All right. So they're both positive here, or one is opposite. You solve those and you're done. So it wasn't really too bad. Okay, solving this one, we're going to subtract x, get our x's on one side. The order in which I'm doing these first 2 steps doesn't matter. So here we're going to move the x over. That gives us x. Because 2 and a negative 1 is 1. Then we'll add 3. There's one of our solutions. So if you were to put in 8 in here, the left will equal the right after you take the absolute value. Let's do this other one here. Using the distributive property, the negative 1, it gives you a negative 2x. Negative times a negative gives you a positive 3. Now, some of you guys have pretty good Algebra 1 skills. So here you could add 2x to both sides. That's fine. You could subtract the 3. You could move this x over. Just move it from side to side so you end up with just x's and then the numbers. I'm just going to go ahead and move the x over here, since that's kind of a pattern that we've developed. Minus 3x, negative 2 and negative 1. And also when you have inequalities, I always move everything to the left with an inequality. But, here, you're going to get the same answer. Subtract 3. Okay, I'm going to get a fraction. So I hope I didn't make a mistake somewhere. Basic mistake. It doesn't look like it. Looks okay. All right, so then you divide by a negative 3. X equals a negative 2/3 and x equals 8. Sometimes I'll copy the problem down wrong. Let me move that up. And just kind of briefly go over it real quick. I don't see anything, so it must be the fraction. So if you were to put a negative 2/3 in here and a negative 2/3 in here, then the left will equal the right. Okay. All right. And then also the 8. If you were to put the 8s in, you'll also get the right answer. Okay, but that's how you do when you have two absolute values. You have the positive, and then one is opposite, just like we do up in these other ones. You have the positives, and then one is opposite. Solve them. All righty. Let's go through inequalities and absolute values. Fun, fun. All right, so again, what we're going to do, we have the inequalities with absolute values. We're going to go through our same steps. These will be done exactly the same. It's just that when we get down to the end and try to decide where our answer is, because it's not going to be dots anymore, it's going to be intervals. You're going to have to decide, is it going to be an and, an intersection, a union, or excuse me, or a union, an or. So you'll have to decide that depending upon this right here. And then I'm going to show you a shortcut on some of these. Let's look here. First off, the absolute values by itself. So we go through the same steps. The absolute values, these are always going to be positive. So you really couldn't have positives less than a negative. So there could be some times where you'll get a no solution here, but just kind of reason through the absolute value. These are positive numbers. There are positive numbers that are less than 4. Yes, there are. The absolute value, 3, 2, some of those. So what we're going to do, the absolute values by itself, okay, we can solve it. So we're going to set up our two equations. X is less than 4, or the opposite is less than 4. So that should look familiar. What do we put in between them? Because in the last section, we were doing ors or ands. Well, when you get the absolute value by itself, if this is a less than, it's an and. If it's a greater than, it's an or. Okay, something just to remember. You'll have to remember that. These have a shortcut. These ands have a shortcut, but we're not going to use it right now. We'll just go ahead and solve both of these. So we went through steps 1 and 2, and then we separated them. The positive is less than 4, and because it's a less than, so that determines that, this symbol, that inequality. Then we have the opposite of what's inside is less than 4. So this one's solved. It's done. This one right here, I guess if you distribute it, you just end up with this. You divide by a negative 1. So x then, Now, here's the tricky part. This is the only difference between what we were doing earlier and with an inequality, that when you divide by a negative, you flip the inequality. So I have these two. We're going to graph it, and then we'll write it both in set notation and in interval notation, our solution. Okay. We've got a 4 and a -4. Let's graph the first one. X's are less than 4. So we have X's are less, which means they're going to go to the left of the 4. It's a parentheses because there's no bar underneath that. And it's going in this direction. This pen's about to go. It's gone. Let's see if I have another red pen. Yeah, this one's better. All right, so that's this one. Now this one right here, we'll go to X is greater than a -4. So we go to a -4. We want X is greater than that, which is to the right. Because it's an and, we want what's in common. And what's in common with these two, the red and the green graph, is the area in between these two. So our graph on the number line would be from here to here. All right, that would be the solution, the graphical solution. The interval notation solution would be -4 parentheses, is not including the -4 or the 4. Interval notation, everything between a -4 and 4. Set notation, oops, excuse me. The set notation would be X's between -4 and 4. All right, so you have those two possibilities depending upon how they want the answer displayed, either interval or with your set notation. Okay, all right. Let's go ahead and look at this next one. Go through the steps and look at the difference between this one and this one. It's pretty obvious that it's the inequality symbol itself. This is by itself. There are numbers bigger than 4. It is possible to have numbers larger than 4. The absolute value of numbers larger than 4. So we'll go ahead and we're going to split it. This is going to be a positive X. Now, because of this right here, this symbol, whenever it's a greater than, it's an or, it's a union. So you'll just be combining. And then we have the opposite of what's inside is greater than 4. And you solve both of them. So you've got the positive and then you have the opposite. So we've got, this is done. Or divide by a -1 to get rid of that negative. Oops, sorry. As soon as I wrote it, I'm like, oh yeah. Because you're dividing by a -1 to get rid of this negative, you flip the inequality. All righty. So you have that -1. So let's graph these. I like to graph before I actually find the solution. Sometimes it's a little easier. We've got 0, we have 4, and a -4. X's are greater than 4. So in looking at that, we go to our 4, but we want X's larger than 4. So they're going in this direction. Now we want X's less than a -4. So we go to a -4 and we want numbers that are smaller. So we're going to go in this direction. Because it's an or and not an and, or it's just a combination of these two. So this is actually the solution. This would be, graphically, that would be the solution. Okay, those two sections are where you can find your answers. Interval notation, how do we do this? Well, we have to do two sections and union them together. So we'll look at this section over here. We have a -infinity because it's going towards a -infinity. So we have a -infinity. a negative infinity, and it's going to stop at a -4, not including the -4. Unioned with, we need that union symbol. We have a parentheses, we start at 4, and we go to infinity. Positive infinity. So these two represent these two separately, and we union them together because this is an or, because this is a greater than symbol. Now, looking at this as far as the set notation, you would just write X is, for this section, X's are less than a -4. That would cover this one. Or, that covers that symbol, X's are greater than +4. That would have the set notation. All righty. Perfect. Let's go through this next part. This is just kind of explaining what we're doing. And what we're going to do is, if you'll notice, I'll go ahead and look at a shortcut. We can talk about that. Whenever you have a less than, your solution will look like this when you have an absolute value. All right. So can we use this to make it shorter, knowing that if you have a less than, the answer will look like this, where you've got the +4 on the right, you've got its opposite on the left, and you have these inequalities, less thans. So we're going to use this one to shorten this one right here. And we're using this B. We're going to use this B. What we've done before is we've kind of used this A section where we divided them into two equations. Now we're going to use this B. So you can only do this if it's a less than. All right. You can't do this if you have a greater than. If it's a greater than symbol, that's this one, we will split the equations into two. So let's talk about this one right here. So it's a less than, so we'll use the B. So we're going to write it -4. You always take the opposite. Less than, what's inside? Less than +4. You solve that for your solution. So now, could you separate it into the two equations where you have the positive and then you have the opposite, and it's an and? Yes, you can solve it that way. This just seems to be a bit simpler, and it can only be used with a less than. So now you solve this, and we talked about this at the end of chapter 8, or 8.1, section 8.1. What we'll do is we're going to get rid of the 2. So our ultimate goal is to get the X by itself. Let me back up. So again, talking about that, we're going to get the X by itself. That's our goal in the middle. So we're going to add 2, add 2, add 2 to all three sections. -2. Now we just have 3x less than 6. Okay. Next step is to get rid of the 3. Divide by 3, divide by 3, divide by 3. So -2/3 less than x, and x is less than 2. So all our numbers between -2/3 and 2 is the solution, but not including those numbers. Let's graph it. There's -1, 2. So we have a -2/3, which is right about here, and we want x's larger. So in other words, we want numbers between these 2 and the 2. And the numbers between -2/3 and 2. That's the graph. Interval notation. The solution would be -2/3 to 2. So, I really like the less than, all right, because this process just simplifies finding the answer. And again, just make sure that if this is a negative, we kind of skip step 1. If that had been a -4, positives are never less than a negative number. So they would not fit that number 1. So kind of reason through to think, is this even worth solving to see? All righty. So, you could pick a number in here just to double check on a test if you wanted to. You could put 0 in, and 3 times 0 is 0. -2 is a -2, but the absolute value is a +2, which is less than 4. All right, so those are your solutions for that one, and how to maybe simplify the less thans. Okay, let's look at another one. Okay, the absolute value is by itself. Okay, we've done that. And now we also need to do the step 2, and that is just to kind of reason through. Can you have positive numbers greater than 6? Yeah, you can. There are a lot of positive numbers greater than 6. So let's go ahead and solve this one. Now this is a greater than, so I'm sorry, there's not a shortcut to a greater than. Whenever you have this larger end here, it's going to be an or, and we have to do the 2 equations. So we'll start, we have the positive, but even these aren't that hard. You just have to remember to do that. It's greater than or equal to 6, or the opposite. We can have a negative in there, because when you take the absolute value, it works. Okay, so the positive and the negative. All right, we'll go ahead. Now you have to use this process if it's an equal or a greater. An equal or a greater. You have to use this process. So, or something similar to it, depends if you know another. Some people flip this and put the negative, but then some people don't understand why they're doing that. Whereas if you have the positive and the negative, it kind of helps you to realize why that some people take that little shortcut. So we have a -2, 4x is greater than or equal to 4. Divide by 4, not dividing by a negative, so we don't have to worry about that inequality being flipped. Looks like we got part of our solution already. Let's go through this one. -4x minus 2. Okay. So then you add 2. I just use the distributive property, multiplying a -1 through. Add 2. -4x is greater than or equal to 8. Divide by a -4. And we know that when you do that, you flip the inequality. And we have a -2. And this is an or. Well, let's see what our graph looks like. We have 0, 1, -1. All right, let's start with this one right here. X's are greater than or equal to 1. So we're going to go to the 1. Yeah, I'll just use those. So it's greater than or equal to. So now we've got our bracket because of the equal. And we want X's that are bigger, which is to the right. All numbers to the bigger, or all numbers to the right of the 1 are larger. Arrow points in the same direction. Okay, X's are less than or equal to a -2. So we're going to go to a -2 and we want X's less than that. So we're going to go to the left for numbers that are less than -2. This is an or, so it's a combination. So that's your solution graphically. Because it's an or, you just use them both. Now, if you wanted the set notation, you would write this. Both of those. X is greater than or equal to 1, or X is less than or equal to a -2. Interval notation I'll do underneath here. Negative infinity to a -2, including that, unioned with 1 to infinity. That would be the solution for interval. Okay, let's look at the next one. Okay, we're going to get the absolute value by itself. That's our first thing we need to do. So we're going to, I'm just going to go ahead and go off of this right here. I won't rewrite it. We need to get rid of the 7 in order for the absolute value to be by itself on the left-hand side. So we're going to subtract 7. So then we've got the absolute value of 4a minus 5 less than or equal to 19. Are we going to have some answers that are kind of yucky, but that's okay. Okay, can you have numbers, absolute value, so these will be positive, that are less than the number 19? Sure, you can. 18, 17. So, I mean, there are quite a few in between, but it is possible. So we've done that step 2. Now we have a less than. So we know because we have a less than, it's a what we call a compound inequality. So rather than split them into 2 and solving them as an and, which you can do, we're going to write the compound inequality and solve it. So you have a -19. Then we have what's inside. And then we have the positive 19. So that's how you rewrite that in order to solve it. And we'll have an end up with a compound inequality for a solution. Okay, we're going to add 5. Our goal is to get the a by itself. And we just add it to all 3 sections. So we have a -14 less than or equal to 4a less than or equal to, wow, 24. Okay. Now divide by 4. I'm going to reduce this by dividing both of these by 2. The a is by itself, and this is 6. So there's our solution, all numbers between a -7/2 or -3.5. Look to see how Pearson wants that entered as a fraction, simplified, or as a decimal. And they'll usually tell you where to round it off as well. You do need to. But we've got 0, so a is between a -3.5 or -7/2 and 6. 1, -2, -3. All right, so we're going to go to a -3.5, and we're going to put a bracket. So our a is between that number and 6 with a bracket. Okay, all numbers between those 2. Okay. Oh, sorry. I should have, it looks like I needed to go further. We're going to put a -3 right there and a -4 just to make it work. So it was a -3.5. And I accidentally put it between the -2 and the -3. So here, -3 and between a -4. Those are your solutions, -3.5. Okay, awesome. Oh, interval notation. Sorry about that. Let's go ahead and put that up here real quick. -7/2 to 6, and including those. So set notation, interval, and graphical. All right, let's do another one. You guys are doing great. Let's go ahead, and we need to get the absolute value by itself before we even determine if we can do this method or if we have to write the 2 equations. Let's go ahead and do that. We'll subtract 3. So that gives us the absolute value of t minus 7 greater than or equal to 1. Are there absolute values are positive. Are there positive numbers greater than the number 1? Yeah, there are. So it's possible. There are a lot of numbers, positive numbers that'll be greater than 1. And because it's a greater than, it's an or, and we have to write the two equations. We can't solve it like we did the last one. So we'll go ahead and we'll write those. We have t minus 7 is greater than or equal to 1, or the opposite of that, inside. So what's inside can be positive or negative. And we solve both of those. I tried to move this up a little bit. It takes a few more steps. But there's not a lot of steps here. So you add 7. T is greater than or equal to 8. Awesome. We're almost done. Here, negative t plus 7. Subtract 7, subtract 7. Negative t is greater than or equal to a negative 6. But we have to get rid of the negative by dividing by a negative 1. So we have t, but when we divide by a negative, we flip the inequality and you get 6. Well, let's graph it and see what this looks like. And this is an or, so we'll just be combining. I'll just write this down here. So they're right across from each other. Let's see what this looks like. We'll go to z, we have a 0. 1, 2, 3, 4, 5. There's our 6, 7, 8. Make sure my positives and negatives are good. It looks like it. So we want t's greater than 8. That's looking at this first one, or equal. So you're going to go to the 8, and we want t's that are larger than that. So it's going to go off to the right. Those are the numbers that are bigger than 8 are over here. Numbers that are less than 6 or equal to it will be to the left. The small end, the smaller numbers. So there's our graph of our solution. It's this section and this section right here. Or I should say this section or this section over here. Set notation, you'd write it like this. Interval notation, you would go a negative infinity till you get to the 6. Unioned with, and you're including the 6 and the 8, to infinity. Done. Awesome. All right, let's look at, oh my goodness, that's the last problem we had to do. Well, again, like I say, if you have any questions, any further questions, something doesn't make sense, please contact me and we can meet and go over some stuff. All right, bye-bye.